Alright, so this is the last problem of this section. It's a word problem. A lot of things we're going to do in this word problem are very similar to what we've been doing already. So it's problem 70 on page 284. It says, after an antibiotic tablet is taken, the concentration of the antibiotic in the bloodstream is modeled by the function. Here's the function. C of t is equal to 8 e to the negative 0.4 t plus e to the negative 0.6 t, where t is in hours and C of t is in, not milligrams, micrograms per milliliter. So those are our units. What is the maximum concentration of this antibiotic within the first 12 hours? Okay, so what they're trying to tell us is to find the absolute maximum of this function here in the first 12 hours, tells us on the interval from 0 to 12. Okay, so all we're going to do is do exactly what we did on the previous problems. We're going to do the closed interval method. So that means we need to find the critical numbers. That's step 1. So we got to take a derivative. C prime of t is equal to, we still got that 8. Now, the derivative of this involves a chain rule. I'm just going to give you the derivative. Negative 0.4 e to the negative 0.4 t. This is a plus. It's going to turn into a minus because of that negative 0.6. So 0.6 e to the negative 0.6 t. Close my parentheses. Now I'm going to do a little bit of simplification here. Equals 8 negative 0.4 e to the 0.4 t. All I did was rewrite the negative exponent as a positive exponent. Minus 0.6 divided by... Oh, I actually had the problem wrong. The original function had a minus sign into it. So when I take the derivative, that should be a plus sign right there. So that means that's a plus sign. I do apologize for that. But this is e to the 0.6 t. Okay, so now what I'm going to do is I'm going to find the least common denominator between these two fractions, and I'm going to add them together. So, if you look, these two pieces are completely different. So the least common denominator is the multiplication of the two. So I still have the 8, all divided by e. Now, if we multiply these two together, think about your exponent rules. You would add the exponents. 0.4, 40 cents plus 60 cents is $1. So you would just get e to the t. Now we need the numerators. So we got negative 0.4. Now this piece is going to be multiplied by e to the 0.6 t because we've got an e to the 0.4 t. To get to the least common denominator, we need to multiply by this piece. Well, this denominator is missing this piece, so that's why I'm multiplying the numerator by that denominator over here. Plus 0.6 e, same story here. To get the least common denominator, this fraction is missing this part of it, so I'm going to multiply this numerator by this denominator. E to the 0.4 t. Close my parenthesis. So this is the derivative of our concentration of the antibiotic. Now, to find a critical number, we need to find where the derivative is equal to 0 or where the derivative doesn't exist. Now, we have a rational function here, so we could be worried about where the denominator is equal to 0. However, this is just a normal, ordinary e to the t function. e to the t is never 0 anywhere on its domain. Therefore, this fraction can never be 0, or the denominator of this fraction can never be 0. Therefore, this derivative exists everywhere. So we're not going to get any critical numbers there. The only place we're going to find critical numbers is when we solve this equation. C prime of t is equal to 0. Now, since we're setting this whole thing equal to 0, we can divide out the 8. We don't have to worry about that. Not only that, it's a rational function. The denominator can never be 0, so we don't have to worry about that. All we have to do is set the numerator equal to 0. Now, I'm just going to add this over. So we get this equation, 0.6 e to the 0.4 t is equal to 0.4 e to the 0.6 t. Okay, so now what I'm going to do is I'm going to divide both sides by 0.4. Now you could type this in on the calculator. You could cover up the zeros and decimals. 6/4, that simplifies to 3/2, and we still got this e to the 0.4t is equal to e to the 0.6t. Now I'm going to divide both sides by e to the 0.4t. That side cancels, and we got 3/2 is equal to e. You gotta remember your exponent rules. We subtract the exponents, 0.2t. Now to solve this, we're gonna take the ln of both sides. So we got the ln of 3/2 is equal to, and then if we take the ln of this side, the ln and the e will cancel, and we'll just be left with 0.2t. So now just divide both sides by 0.2. And then we have our critical values. Critical value is t is equal to, now instead of having a 0.2 on bottom, this is a 1 divided by 0.2. 1 divided by 0.2 is 5 ln of 3/2 hours. So there's our critical value. Again, we don't have any other critical values. So we need to find the function value of 5 ln of 3/2. Now, I punched this in on a calculator. I didn't give the exact value of the function value. This is approximately 1.185 micrograms per milliliter. So now we also have to find the endpoints, the function values of our endpoints. Oh, I'm using F here. We should be using C because it was C of t. So if I plug in 0, well, you don't even have to plug it in. If you think about it, you haven't injected yourself with any antibiotics. You haven't taken any. At time equals 0, you should have a 0 concentration, micrograms per milliliter. So now C of 12. The function value at time is equal to 12. Again, if you plug that in, I'm using a calculator for this, but I have the numbers written down. Micrograms per milliliter. So, step 1, go over it, the closed interval method. We found the critical value and then found the function value of the critical value. We found the values of the endpoints. Now all that's left is to compare. We want to find the maximum concentration, so max concentration occurs at, I think they only asked us for the time. Let's read the question one more time. What is the maximum concentration? Okay, what is the maximum? Not when does it happen. Maximum concentration of, right there, 1.185 micrograms per milliliter. And that's it for 4.1. If you look in your homework, there are a lot of you do have a couple word problems like this, or one or two or something like that. But all these problems are very similar in this section. You take a derivative and do the closed interval method.